All right. So next time I do a video like this, I hope I will be more enthusiastic. Um, but that being said, hi everybody and welcome to my talk about, it's not a good start, about Git and writing history. Excellent. All right. So hi, I'm Jachim Coudenys, and I work at a company. I work at a company in Belgium called Combel. We're a hosting company, and at Combel, I help automate a lot of stuff, and we do a lot of things with code. So so we like to have a clean history of all our commits in Git. So in a way, we all write diaries. So small question: who's keeping a diary in real life? Don't be ashamed. Yeah, I see a couple of hands. As a matter of fact, we all use diaries. This clicker is not working. So what is a diary? A diary, according to Wikipedia, a diary is a record with discrete entries arranged by date, reporting on what has happened over the course of a day or another period. So Wikipedia even goes a bit further. Diaries undertaken for institutional purposes play a role in many aspects of human civilization, including government records, business ledgers, and military records. So we have diaries everywhere in the world, and it helped us do a lot of great things. And we had this morning we had a little poll, and this is a picture that half of the audience here are developers. So as developers, we all write code, and because we write code, we also have to keep a diary, because the code itself doesn't really explain what is going on. So we have to communicate about what the code does in a way. And the primary goal of a software developer should be to communicate their intent to future developers. Future developers are like just a random number, 70% of the times your future you, so you reading your own code. So it's very important that we have a lot of context about about how a specific piece of code was constructed. So I don't know if anybody has seen this cartoon. So you have two lines of code, and maybe you didn't write it, so you have to compile it in your head. So you read the lines of code, you start compiling it, you start creating a whole graph of what happened, of what could happen, where the code came from, where the variables came from. So you have a lot of things in your head that could go this way, it could go that way. And then your colleague comes and it says, hey, I sent you an email, did you see it? And then poof, that whole thing in your head is gone, and then that colleague walks away, and you have to start all over again. So we have to document our code, and you could do that by including a lot of documentation inline in your next to your code. You could have external documentation, you could have API generated documentation, but we prefer the version control system. And to include another picture of this conference, we saw pipelines coming by every once in a while in the presentations. And this is from the keynote from yesterday, and you see that version control is the base of the complete pipeline. So we have a lot of code, and so it's a pretty important factor in the complete pipeline. So I talked about context. Re-establishing the context of a piece of code is wasteful. so we can't avoid it completely, so our efforts should go to replacing it as much as possible. Commit messages can do exactly that, and as a result, a commit message shows whether a developer is a good collaborator. So this is a quote from open source, when you see a lot of different code, and because you work a lot together, you have to write very good commit messages and code, of course. But you have to write good commits so that the other developers know what you were doing at the time you wrote the code. So, who's familiar with the Richardson maturity model? Maybe the name doesn't ring a bell, but if you see the graph, you may be familiar with it. So it's about the different levels in REST. So at the bottom, you just have the basic usage of the API. Then you start using resources. Then you start using HTTP verbs like post, blah, blah, blah. And then you have the hypermedia controls. And at the very top, you are at the glory of REST. So this is not a talk about REST. It's not even a talk about this maturity model. But this is the way the presentation was built up, because I created my own little Jachim's commit maturity model. So we have a couple of levels, and every level we get a little more advanced in the practices we use to write commits. Every level talks about commits, about the messages, and then the CLI and different tools that we use. So level 1. Here we talk about Git Basics. So who's using Git? So almost everybody. So this is really basic, but it's necessary to have the groundworks for the rest of the presentation. So this is a local version control system, better known as just your local computer. This can be your IDE local history setting, or it could be your very inventive file naming scheme, like version 1.sh, version 2, version final.sh, version final.1.sh. So this is not a very good version control system, but it's something. So we evolved, and then we came to central version control systems. CVS, Subversion work like this, and they keep a version database on a server. And you have a lot of clients which check out specific versions of a file. So in this scenario, the complete version database is on the central server. So if a user, if computer B wants version 2, it will just ask the server, give me version 2, and then the server will send them that specific file. In a decentralized version control system like Git, the version database is on every node. This can be, a server component can be involved, like GitHub or GitLab, but this is not required. So you could just start using Git and send the Git repository back and forth over two computers. So every computer has the complete history on its local machine. And this is how Git works, how we all used to do things right now. Next to the server component of it, the old systems work like this. So you had version 1, and you committed all the files into the version control system. And then the version 2, you changed 2 files. And the version control system would keep the diff in the system, and every time you ask a specific version, it would try to it would apply all the diffs to it, and then, for instance, here version 4 would have a complete diff applied version, and you would be sent that. In Git, however, every file is just stored as is, and in this case we have A1, this is a new version of it, C1, and B is exactly the same, so it is just a pointer to the previous file. So every time you do something in Git, it will store the complete new file as a version and or a reference to the previous one. And then the last concept is in Git, we have different stages. We usually start by checking out the .git directory. So this is the complete version database. We ask a specific version from the database, and then we do a checkout in the working directory. And then we have the staging area, which many people tend to forget because they use git commit -m and then type or -am, and then they just skip the staging area. But you can add different files to the staging area and then commit the staging area to the Git repository. This is a bit important because you can do some tricks with this. To go a bit further, this is a Git commit which always has a parent, unless it's the first one. So the Git commit always points to a previous parent one, and the orange blocks are the labels, are the branches, and the branches are just a label pointing to a specific commit. And then here we have the special head label, and that label is where the working copy is at. So here we have testing which was created from master, and the working copy is now pointed at master. So in the next slide, we see that we changed the working copy to the testing branch, and we created a new commit in that branch. And that branch is pointing to the previous one. So if we then switch back to the master branch and we do a commit, we see that we have diverged and that we created new branches. So this is the inner workings of Git. And that concludes the Git Basics. So we're level 1. So in REST we had the swamp of box, so plain old XML, and this is the swamp of plain old random commit messages. So this is a cartoon this is something we want to avoid. So at the end of this presentation, you won't have your version, your commit log looking like this. So this is what we want to avoid. All right, on to level 1. If we want to have good history, we want to have atomic commits. And atomic commits are small, so Git commits are very cheap. It's not. It's just It's not a big deal if you do a lot of commits. So just keep them small, and they should address one problem and one case at a time. So if you change something at a user login, don't mix that with the config settings somewhere else in the same commit. Just make sure they're atomic. And if you commit something and somebody else does a checkout, nothing breaks, that everything is contained in that one commit. With commit messages, say what you want, what and why you did instead of how. If somebody wants to know how you did something, they just open the diff and they see how you solved a problem. What they want to know is why you did it, and that's why you need to use the subject. And also something not that many people know is that you can write a body in the git commit messages. Always use a body if it's required. If you do a typo fix, you don't have to include the link to an online dictionary in the body. If it's only use the body if it's required. But as you start using it more, you'll see that most of the time it's required. So why do I stress about Git commits and how you should write them well? Because I was at Johannes' talk yesterday, and I was too late to take a picture of the previous slide, because on the previous slide there was the number of how many commits, I don't know, per year, or what they have up until now. But if you take the 200 million pull requests and you say that every pull request has 1, 2, or 3 commits, you know, we all write together a lot of Git commits messages, and we should really do a better job at it. Because if you look at this overview, it's still from 2016. I don't know if it got better or worse, but this is a an overview of 151 million commits where they stripped away the merge commits. And the top ones are not very, well, not only the top ones. Every line here is not that good. But the top ones, we have initial commits, we have update readme, we have an empty one. But the two first ones are not the fault of GitHub, but it's if you follow the normal readme of an empty file, they suggest a commit message with initial commit. Everybody copy and paste that. And the second one, update readme, if you use the inline of the online editor of GitHub, they suggest update and then the name of the file. And because nobody changes that and just hit submit, that becomes the second most popular Git commit. But all the rest, you have push, fix, cleanup, test. That doesn't say anything about why you did that particular change. So time for some tools. Everybody knows git log. So this is why we want to use, why we want to write nice commit messages. We see the commit ID, we see who did it and when it was done, and most importantly, we have the subject. So in one line, we see what was going on, and then we have the body where everybody can type anything they want. The next one is the minus grep. So because you start writing decent commit messages, you can go back in time and look where something occurs. So you know something went wrong with the queue, and you want to know who did it or why it was introduced. So here we search for queue, and we can see somewhere in this output, probably here at the end, that the word queue is in this. Oh, I don't know. Queue.php. Yeah, thank you. So this is something that's very useful. Next up is minus uppercase S, and this is very useful because it's not looking in the subject or the body, but it's looking in the diff. So here we are looking for bcrypt, and here we see that bcrypt was found and it was removed in this commit message. So why is this so powerful? Imagine you do a checkout and you try to compile your code, and you get a undefined method, blah blah blah. Then you can just do git log menace, blah blah blah, and you see when that method was introduced and when and why it was removed. So this is again very useful to go back in time and use git log. All right, that was level 1. Who's already on level 1? Who does atomic commits? Yeah. All right. On to the next level. So we had atomic commits, but now we want to have pure atomic commits. And pure atomic commits always separate code formatting and code changes. So if you have an IDE who really likes a new line at the end of the file, and the file you were editing doesn't or didn't have that one because your colleague didn't use the same editor, and you change something in that file and you hit save, then your editor will automatically add a new line at the end of the file. And if you commit, you basically have two changes that are unrelated but that are in the same commit. The new line at the end is not that bad, but imagine that your editor strips away all the white space at the end of lines, and there happens to be a lot of white space by another developer. If you hit save, then the complete file will be rewritten, and your change will just be gone and be untraceable in the complete change set. So always use a separate commit for that. And if you are in the if you have the problem that I just described, that your editor does something, you can use git add -- patch or git add interactive to do commits from a dirty workspace. So if you do git add -patch, so imagine we have the single file, and where we had the fix and the new line at the end of the file. If you do git add -p, it will present all the changes in chunks. So it will open, you will see the change from the one file, and you see first that you did the change, and then it will ask you, do you want to add it to the staging area? Then you say yes, and then it will go to the next chunk, and then it shows you the new line. Then you can say no. And if you then do a git status, you will see that the same file is both in the staging area and in the working directory changed area. So you can commit parts of a file. Git add interactive does basically the same. So why it's important to always separate everything, because if you ever had to revert something that took you months and they're not happy with it, and you want to go back and revert some commits, you want all those changes to be as separate as possible, so you can actually revert one commit without breaking newer commits. And if you use something like Git Bisect, Git Bisect helps you pinpoint a faulty commit by going back and forth in your Git commit history. If you use decently separated commits, that will be more useful. So next to make sure you commit only clean things to the repository, rewrite history if it's necessary. So Git is distributed, it's private, and it's very flexible. So as long as you didn't push something to a remote server or to your colleague, it's completely private, and you can rewrite the complete history without anybody on the other side knowing it. You can do the same thing if you already pushed something, but you will get into the very different problems, and your colleagues won't like that. You can rewrite history with git commit amend, and that will change the previous commit. So if you did a typo in a file, you can just edit that file, do git add the specific file, and then git commit --amend. Then your editor will open, and you will see the commit message from the previous commit, and the new file, and the file can be added. And if you then commit it, you will have a completely new commit ID. If you only see, for instance, the typo a few commits in time, you can rebase your history. So you have an initial commit, and then you have then you do another commit which has a typo in it. Then you do 2 more commits, and then you see the typo, and you want to fix the typo. So you can instead of just creating a new commit which says fixing typo and then the commit ID from where it was, you can just say git rebase interactive. Say that you want to rewrite from a given point in time, so the commit before the typo, and then the editor will show up and show you all the commits, and the actions you can take. So then you can say the first one was good, the second one with the typo I want to edit, the following 2 ones I just want to keep as they were, and the last one I want to remove. And then if you run that playbook, so to speak, it will just stop at the second commit. Then you can fix the typo, commit it, and then the rest of the rebasing will occur. So how to write good commit messages? You might have a look at the length. So it's not, you want to be very short in the subject, what you want to see. So the main plan, is to have the subject line maximum of 50 characters and the body at 72. And also stop using git commit -m, just do git commit, and then you have the Vim or whatever editor you want. And then you can start filling up the body. And if you fill up the body, reference tickets, reference pattern pages, reference manual pages. So if you read something in the in a manual page from the framework you're using, just commit the link in the body so everybody knows why that happened. And if you do it with full URLs. So the reason why we want very short very short subjects is because Git log one line uses it. The Git rebase interactive uses it. So you want to have a very very clear thing of what happens in a commit because you're rewriting history with it. The merge summary, Git short log, and a lot of different tools are using it. GitHub also tries to help you, because if you use their commit form and you start reaching the 50 characters limits, they will show you a pro tip: don't do this. And so it's a nice little feature. So the next thing is graphs. Not these graphs, the more prettier version of graphs, the Git log graphs. Who's using graphs? So not that many people. So graphs are just a representation of the branches that you took, and shows you when you merge something back to master or the other way around. So in the more proper version, this is GitLab, a pretty old version, but here you can see that we have master chugging along, and every feature gets merged in master. So this is pretty neat, and you want to keep it that way. So we don't want to end up with something like this, where the lines just cross constantly. So if you see something like this, yeah, it's not that good, and it will get you into trouble later when you want to figure out where something went wrong. One reason why this occurs a lot is because of merge bubbles. Who knows merge bubbles? So every time, I don't know if Git, the defaults now are have changed, but every time you pull changes from a remote server, you will create a merge branch master from GitHub or whatever.com. And if I search for that one, I come up with 5.6 million commits that basically could be avoided. And why do they happen? So this is my local commit, and I pushed it to GitHub. And my colleague wants to work on something, but they want to pull my changes in first. So what they do is they take this commit, so they have my commit and on their branch, and they have to merge it into their branch to continue working. So this is basically this is just something that could be avoided, this whole bubble, and this complete merge commit could be avoided too. So the difference, if I go back, the difference here is that you should use rebasing instead of git merging for this particular scenario. So here we have the remotes, and we're working on this master, on this feature branch, and we want to have these changes in our feature branch. So in the previous example, we take these changes and we create a new merge commit locally. And this is a new commit, but it's a commit that could be avoided by using rebase. So rebase is basically, it takes the 3 commits that we have locally and it keeps them in memory. Then it throws away the branch. Then it checks out or then it creates a new branch from the new master, and then it applies all the commits that it had in memory. And the stars here are. This is rewriting history. So the previous commits are gone. So this is why you don't you're not allowed to rebase or rewrite history on master or your develop branch, because other people start from there. But in this scenario, just to be rebase, because it's much nicer. It's much nicer in the end. All right, we survived level 2, on to level 3, and we will write suburb commit messages. And suburb commit messages, they answer 3 basic questions. So they answer why was this change necessary, how does this address the issue, and what side effects does this change have. By answering these 3 questions, you kind of come up with this, and this is a very meta commit, because it's Torvald who created Git, committing the way a commit should be created by also using the commit strategy that he recommends. So we have a subject line, we have the body, and you can use paragraphs, you can use bullet lists, you can do links, and at the end he uses a mail header like format for key value things. So you can write complete. If I fix a bug, I mostly even copy and paste the complete stacked phrase and then just put it if it's not containing sensible or sensitive information, but just put it completely in the body. The more information there is, the better. So this is a commit from the Bitcoin library, and here the subject is we changed the confirm target from 2 to 6. You could see that in the body, but if you look at in the body, that won't show you a lot why something happened. And here they say we have RSC meetings, we have a commit, we have a ticket number. This is the reason why they did something. So this is a very good example of explaining why something changed. Superb commit messages also are in the imperative. So instead of saying fixed bugs or fixes bugs, you say fix bugs. This is the way git merge and git revert work. So if you do git revert a commit, it creates a commit on your behalf saying revert and then the commit number. So if you write in this tense, you can use your commit subjects as if applied, this commit will fix this bug. And if it's possible, link to previous commits. So git revert does pastes the complete hash in the commit. And this is very useful because if you use GitHub or GitLab, they will create a hyperlink of that commit. And in the case, if you commit something with a commit ID and you click on it, you will see that they even create a comment on the commit itself. So then you have you can easily traverse through your commit history. You could use hooks. Who's using hooks in Git? All right. So these are client-side hooks. And hooks are something that can help you with different things, and you can use it to automate stuff. If you say this fix bug 1, 2, 3, and you push it, and the remote hook could close a ticket for you. If you're using a strategy where your branch name always starts with the ticket number that you're fixing, you could even create a Git hook which reads the current branch name and then uses that number to prepend. If you do git commit and your editor opens, you could then inject the ticket number that you were trying to fix. You could also validate commit messages if the correct format was used. Issue numbers, I just say you could include it. I'm on the fence of that because it creates a lot of comments in the tickets on GitHub or GitLab, but I tend to use it because it's nice that I just go to a commit and I can see what ticket it was for. So by using all the things I just told you, every line of code is always documented. If you use git blame, every line of code is documented. We know when it has changed, who changed it. We have the commit ID, and your most editors have support. If you hover this information, then you just see the complete commit message. So this is something that's very useful, and you don't have to over comment your source code, because your version control system contains most of the logic. So here I use git blame. Do yourself a favor and add an alias, git praise, which is an alias for git blame. So if you see some code that was excellent, then you can just run git praise, and then you see who wrote that piece of code. All right. So to conclude, you have to agree on something in your project or in your company, of how you will do these things, and you have to document it. So have a decision made over the style of the commit messages, the content, what should be in it, the metadata, so the key values at the bottom. Ditch GUIs for commits. You don't need them, and you can do a lot of tricks like the Git hooks. When you're ready to commit something, read your code first with git diff and see all the changes that you are going to commit into the repository. And if you see that something got mixed, so sometimes you're dived in and you created a big feature, and you see that if you inspect the code with git diff, that you could. This is the user interface. This is something different. And if you see that happened, use git add patch, something like that, to split up your commits. Don't do end of the day or code drop commits. So I sometimes see a developer which uses git as a backup. So at the end of the day, say, all right, so this was all I did, and then commit, push it. Oh, it's safe in Git. Don't do that. You will have a very difficult time seeing what the intentions were. And with all the things you do, check your impact on the commit graph. So if you commit, if you merge, if you rebase, or even squash, check what you're doing on in the graph, and that will help you to get better at the end of the day. And to conclude, rewrite history if it's necessary. It's not that hard, and it will help you in a month, in a year, in 4 years. If you need something, if you need to know something and why something happened. Thank you very much.
Thank you, Jachim.